The first problem is calculate the dryness fraction of steam which has 1.5 kg of water in suspension with 50 kg of steam. So first write down the given data. What is the mass of dry steam? The mass of dry steam is you take as ms, it is 50 kg. So this is the mass of dry steam and this is the mass of water. Okay, so you keep it as ms and this as mw. It is equal to 1.5 kg. You are asked to find the dryness fraction. The dryness fraction x. We know that the dryness fraction x is given by mass of the dry steam divided by the mass of dry steam plus the mass of water in suspension. So I can write like this, 50 divided by 50 plus 1.5. So this will be equal to 50 divided by 51.5. If you solve this, you will be getting x is equal to 0.9708 or I can say 0.971. So this is the final result. So you finally write this dryness fraction x is equal to 0.971. So it implies that it is a wet steam. Since the dryness fraction is less than 1, x value is less than 1, we can say that this is a wet steam. Next question, what amount of heat would be required to produce 4.4 kg of steam at a pressure of 2 bar and temperature of 250 degrees Celsius from water at 30 degrees Celsius? Take specific heat for superheated steam as 2.2 kilojoule per kg Kelvin. So first you write down what is the given data. So given data is the specific heat of superheated steam is given as 2.2 kilojoule per kg Kelvin and 4.4 kg of steam has to be produced. So this is the mass of steam. The mass of the steam is equal to 4.4 kg. So this steam has to be produced at a pressure of 6 bar and a temperature of 250 degree Celsius. And the temperature of water is 30 degrees Celsius. Okay. So this is one data, 1, 2, 3, 4, 5. So 5 numerical values are given. You check it whether all the values you have entered in the given data. 1, 2, 3, 4, 5. So these two temperatures are related to the steam. So what you are asked to find? First, draw the schematic diagram. I am having water. Water at 30 degrees Celsius. So from this water, I have to produce steam. The temperature of steam is 250 degrees Celsius and the pressure is 6 bar. So to produce steam from water at 30 degrees Celsius, what I have to do? I have to heat this water. Then only water will be converted into steam. So to convert this water at 30 degrees Celsius to steam at 250 degrees Celsius and 6 bar, what is the amount of heat that I have to supply? Also given the mass of the steam that has to be produced is 4.4 kg. So 4.4 kg of steam has to be produced at a temperature of 250 degrees Celsius and pressure of 6 bar from water at 30 degrees Celsius. Now, what is the amount of heat that has to be supplied? You are asked to find the heat supplied. Okay. You draw the TH diagram. From the TH diagram, you will be able to solve the answer. So I am having a graph like this. In this, the y-axis is temperature and the x-axis is enthalpy. Okay. I am heating the water from what temperature? From 30 degrees Celsius. You take this as 0 degrees Celsius. 0 degrees Celsius. But I am heating the water only from 30 degrees Celsius. So this is your starting point. From 30 degrees Celsius till the saturation point or boiling point, I will be heating the water. Okay. Then after that, what happens? Liquid will be converted into vapor. Then it will go to the superheating area, superheating region. Okay. So you should be in a position to say what the various points are. So at this point, what will be the temperature? At this point, corresponding to this, you will be having the saturation temperature Ts, because 30 degrees Celsius definitely it will be in liquid phase. If you heat this, what happens? The temperature rises slowly. If you apply heat, the temperature rises slowly till the saturation point. In the saturation point also, it will be in liquid phase. Here what happens? It will be converted from liquid to vapor phase at a constant temperature and pressure. If you heat again, what happens? It will be converted to a superheated steam. Okay. Now you have to find whether this steam is a dry steam or a superheated or a wet steam. Okay. So first what we have to do is corresponding to 6 bar at 6 bar, what is the saturation temperature? You check this. From steam tables or Mollier chart, you can find what is the saturation temperature corresponding to 6 bar. So this comes around 158 0.8 degrees Celsius. If you have any textbook, you can refer this, check this value corresponding to 6 bar. So Ts is 158.8 degrees Celsius. But what our condition is, our temperature, our steam temperature is greater than Ts. Our steam temperature is 250 degrees Celsius. Here saturation temperature is 158.8 degrees Celsius. So if the temperature is greater than the saturation temperature, what it indicates? The steam is a superheated steam. So superheated steam means it will be lying in this inclined line. So let us mark this as 1, 2, 3, 4, 5. So at point 5, your final point will be there. That is 250 degrees Celsius and 6 bar. So this will be your point 5. And your initial point is 30 degrees Celsius. So from state point 2 to state point 5, I have to bring. So what is the amount of heat to make this conversion? So first inference, the steam is a superheated one. Then we have to find what is the amount of heat added. So what is the formula for finding the enthalpy? See, you have to find the enthalpy of superheated steam because your steam is a superheated one. So we have to find the enthalpy of superheated steam. The enthalpy of superheated steam. So this is given by HF plus HFG plus CPS steam temperature minus saturation temperature. Okay, steam temperature minus saturation temperature. So in this, I have to find what is the HF value, what is HFG value, what is TS value. So TS value, we have already read it from the steam tables. Now you find what is HF and HFG value. So this values you have to take at a pressure of 6 bar. So at 6 bar, what is HF and what is HFG? That is at enthalpy of superheated steam, you can denote by H sup. Now at 6 bar, what is HF value and what is HFG value? Because your steam is in superheated region. So see, I have to calculate this value. Enthalpy of superheated steam is given by this formula, and this is the diagram. From 0 degrees Celsius to this temperature, what is the amount of heat added? So you can find like this: HF plus HFG plus CPS T minus TS. Instead of this HF plus HFG, I can directly take Hg value also. Either you find HF and HFG and sum it, or you can directly use this formula. So either the red color formula or this black color formula. Any formula you can use because HF plus HFG is Hg. So I shall be calculating this problem with HF and HFG. So HF is 670.4 and HFG is 2085. The unit is kilojoule per kg. If you add this, you will be getting Hg. Either you can use this or you can use this value. Okay. Now you substitute H soup is equal to HF is equal to 670.4 plus 2085. 2085 plus what is the CP value? CP value is 2.2. CP value is 2.2. And what is your temperature? It is 250. This is the steam temperature. And what is the saturation temperature? It is 158.8. So this is your saturation temperature. And this is your steam temperature. You can also convert this value from Celsius to Kelvin. You'll be getting the same result because here also I'll be adding 273 and here also I'll be adding 273. So there will be no difference whether if you calculate in Celsius or in Kelvin. You'll be getting the same value. If I calculate this, what you'll be getting? You'll be getting 2956 2956.04 will be getting. You can take it as 2956 kilojoule per kg. So this is the heat that has to be added per kg. Okay. (2946 kilojoule per kg). Up to now, what we have done is temperature, enthalpy, up to now you have calculated the total heat for 1 kg. That is, if your point is here, that is 250 degrees Celsius. So this heat you have calculated. That is from 0 degrees Celsius to 250 degrees Celsius. What is the amount of heat you have supplied? But what is your initial condition? Your initial condition is 30 degrees Celsius. So from the total value, I can write like this. Net amount of heat added per kg. So this is equal to the total enthalpy of superheated steam minus this value. See, I have to find only this value. Okay. This value, H value, I have to find. But I have the total value. So how I can calculate? H is equal to H soup minus this you take as Hx. H soup minus Hx. So this value is Hx. And from here to here it is H value. So H is equal to H soup minus Hx. So this value I have calculated. So this value is 2956. 2956 minus, what is this value? This is the value of enthalpy, or the amount of heat that has to be added to bring the water from 0 degrees Celsius to 30 degrees Celsius. See, I am having water at 0 degrees Celsius. From this to 30 degrees Celsius, what is the amount of heat that is to be added? Because it is already in 30 degrees Celsius. So what is the formula? mCp delta T. If I am taking for 1 kg, this formula will become 1 into Cp of water. Cp of water, it is equal to 4.18. And the temperature difference. What is the temperature difference? 30 minus 0. It is equal to 30. So this will be equal to 125.4 kilojoule per kg. So to bring the water from 0 degrees Celsius to 30 degrees Celsius, this much amount of heat has to be added. But already your water is in 30 degrees Celsius, you have to subtract this value from the total value. So I can write like this: 2956 minus 125.4. This will be equal to 2830.6 kilojoule per kg. So this is the amount of heat that has to be added for per kg. But in the question you are asked to find for 4.4 kg of steam, the heat added is mass of the steam into the enthalpy. Okay. So what is the mass of the steam? It is 4.4 into what is the enthalpy? It is 2830.6. If you multiply this, you will be getting 12454.6 kilojoule. So this is your final result. So this much amount of heat has to be added to water at 30 degrees Celsius to convert it into steam at a temperature of 250 degrees Celsius and 6 bar.